All right, we're looking at another question. So it says find the equation of the plane through a plane through three different points. A is -1, 2, and 0. B is 3, 1, and 1. And C is 1, 0, 3. So these 3 points would form a triangle. And you've got to imagine a triangle is flat. So it doesn't matter that, all our X points are different, all our Y points are different, and all our Z points are different because that triangle sits on a plane of some form. So to start this off, we're going to use vector form. Now, this is not in our course, but it's reasonably simple to think about. Our form of the equation here is going to be R through A plus S of, I'll just use V and then plus T of W, where these are just direction vectors. So realistically, if we think about this problem here, and I'll just draw it out a little bit. So we've got A here is -1, 2, and 0. We've got B here is 3, 1, and 1. And C here is 1, 0, and 3. We're going to find, let's just find, I'm going to use A, B, and C, B. So we can find A to B. Now, the reason I'm picking these is because they've used them in the textbook as well. So if you're looking at the hard copy of this, so they've picked these two vectors here. So A to B, let's go below it. So A to B is going to be equal to 4 because we go from -1 to 3. -1 because we go from 2 to 1, so we go down by 1, and then 0 to 1 means we go up by 1. So we've got A to B and then C to B equals, we go from 1 to 3, so we're going to go up by 2. We go from 0 to 1, so we go up by 1, and 3 to 1, we go down by 2. So I've got 1 and -2. Okay, and so in this particular example, because I'm matching the textbook, they've gone, well, our fixed point here, they've picked 1, 0, 3. So you notice here they've picked C. It doesn't matter. You can pick any of these. They're all actually, because of the way these vectors work, any of these points will give you the correct answer. They will be different though. So this one here, they've used 1, 0, 3. So 1, 0, 3 is our fixed point, and then plus S. And then we just need one of these direction vectors here. So let's take the first one, 4, -1, and 1. So 4, -1, and 1. Plus T, and our other vector here is 2, 1, -2. And that is it. We just need to define S and T so people know what they are. S and T are real numbers. Cool. Now, we're going to go into Cartesian form. So I've already started down there. I've already got a little bit prepared. In this here, we've got these two direction vectors here. We just need to find the normal. So what we're looking for is we've got to find the normal for these. So I'm going to move this down a little bit because you'll notice that I've actually cheated. So we've got, from previously, our normal vector is going to be V cross product, should do that a little bit bigger, W, which means we're going to have the cross product of 4, -1, 4, -1, and 1, and that's going to be cross product with W, which, so these here, I've just done, this one here is V, and this one here is W for this particular exercise, so maybe I'll highlight them. Let's go yellow. Maybe we'll pick a different, let's use this green. So V, W, we've just used them for here. And so we've got this here, 2, 1, and -2. And so now we've got this, we get our vector out of this, and it equals, now, if you haven't noticed, that's this cross product here. I've put this in my graphics calculator. I don't want us to have to keep doing this. So you've done this before, but this answer here equals 1, 10, and 6. All right, now, in our last example, I used the textbook example, which is this form here of the Cartesian the Cartesian equation of a plane, but this is the SACE one, which is the A are the same, even though the SACE formula sheet will have it in capitals. B is the same, C is the same. But you'll notice here the D is on this side here. And so if we were to rearrange this, these two forms, they differ by D would equal negative lowercase d. Everything else would be the same, but let's use this one here for what we're going to do. So copy, I'm just going to paste that down here. So we've got this, and so with our normal, we've got, well, it's going to be 1x plus 10 times y plus 6z plus d, which we don't know, equals 0. Okay, and then you've just got to pick a point on the line to sub in to work out what d is. So d in this space here, d is going to be equal to, so we still use that to figure out what d is. So you sort of need this here. So I'm going to copy that down. So I'm going to just paste that here, because this bit here, if you remember, this is going to equal negative capital D. So in this space, I've made this a bit simpler for myself, but I'll do it by hand here. So we had our A1 plus 10 plus 6. So that was that there. We need to pick a fixed point then to put these coordinates in. So I've done A, B, and C from our normal vector, and now we need to just find a point we know to then come up with the D for our equation. Now I've already picked this point A, which they used in the textbook, and I went -1, 2, and 0. And this equals this equals 19 here. Now you'll notice I actually have, we'll come back to this in class, but this is actually the dot product here. You'll notice that if you put a coordinate in here, I'm actually dot producting the normal, and that value that comes out gives me the equation here. So that 19, so we've now figured out that negative D equals 19, therefore D equals negative 19. And so our equation here is going to be x plus 10y plus 6z take 19 equals 0, or if we're following the textbook, it's equals 10y plus 6z equals 19. So that example's all done there. Now, I did cut corners by using the graphics, but you may as well, because we need to be quick in